basics concepts I need to cover, but one last thing on page 44 is we need to figure out, everything we've done so far was assuming that data is normally distributed, but we're going to have to test it. Sometimes you have to test it to see if you can actually call it normally distributed. Okay, so this is just recall the properties of a normally distributed data set, right? 100% is under the curve, the graph will be symmetric, the mean is at the center, half of the values are below and half are above the mean. You've got your empirical rule, all of those things are still true. This is maybe something to watch out for. The mean, median, and mode are going to be equal or very close to each other if data is indeed normally distributed. Okay. So look at this, these two graphs here. Which one would you say is normally distributed between these two? Right or left? Left, right? That doesn't sound right. The left one is the one. So it's never going to be perfect. Very few, seldom in real life do you have a perfect bell curve, but you can, to a certain degree, see that this will result in a bell curve which is symmetric. This one here, if you were to graph this, okay, it is not going to be a symmetric bell curve. So this one is not, this one is, right? So graphically, it's fairly easy to figure out, but if we had to graph every data set we had, and imagine you've got thousands of values, it'd just be way too time consuming for us to do that. So this is what we're gonna do in order to check for data being normally distributed. So here are the steps. I would have this on my study sheet because I do ask for it on the test, okay? And you should be able to do that on the quiz coming up. So obviously we start with finding the mean and the standard deviation. And then we sort it if possible. Sorting is gonna be critical to speed up the process. Then we create a frequency line, okay? This is, sometimes it's a frequency, some questions differ here. I just changed it to frequency line, but this is what you need to do. The middle is the mean, so I'm going to use a different color for this. The middle is the mean, and then we add 3 standard deviations to the right and 3 standard deviations to the left. Okay? Fill the values into bins created in step 2. So here's where you want to grab a ruler, or you don't have to, but try to make a straight line. So basically what I do when I have my mean and my standard deviation, this is not to scale. I'm not drawing this to scale. Okay? You simply want to have a line and you want to have bins. The middle right here is going to be the mean. Okay? And then you make 3 bins towards the right. So this would be plus 1 standard deviation, plus 2 standard deviations, plus 3 standard deviations. And you do the same thing going to the left, not to scale at all. This is just for us to speed up the process. Okay? And then you're going to have your numbers, right, in a table like here. And we're going to place them into the bins, right? Every single number, we're going to see where does it fit in. Because these are all going to be actual values, okay? So let's say your mean is 100 and your standard deviation is 10. This would be 90, 80, 70, right? 70. So from 70 to 80, you look at all your values. Oh, this value is 75. 75 would go into this one here. So we're actually going to do this. Okay, we're going to put numbers in. Maybe we're even going to do 5. Okay, so we're going to kind of do our tally in those bins. All right? The most important being you start with the mean at the center. Okay, you start with the mean. So we're going to check right off the bat where our numbers fall in. Then we do the check. This is where the 95, 68, 95, right? Check to see if data follows this rule. Okay. Note, if you're off by more than 5%, we say that it will not follow the rule, so it's not normally distributed. If it does, data is normally distributed. So these are the steps. I'm going to dive right into it. This is just for reference later on, if you look through this. So let's go to 45. And I've already asked you to type this in. What is the data in this case? It's the movie collection, right? Length of each movie in minutes. So every single point in here is the minutes, the length of the movie in minutes. A, determine the mean, median, mode, and standard deviation of the data above. So let's do that. Enter into L1 and then sort. I would say sort right away. Do not sort frequency tables, okay? I need to remind some of you. This we sort because it's a bunch of raw data. So we're going to go stat, edit, we enter it all into L1, we go back to stat, we sort L1, you should all do that, okay? And then let's do our calculations here. One variable stats, L1, and let's figure out our mean, median, and mode. Mean is 102.5 minutes. Our median, anybody figure it out already? Our median is 99 minutes. And our mode, how do you do the mode again? Go to your sorted list. Okay. And I will tell you already that it is, just write this down because it's not actually that crucial for 89, 99, and 100. There are 3 modes in this case. Sorry, I'm going to zoom into that. There are 3 modes if you were to go through it. Okay. This is not the important part. The standard deviation and the mean is the important part. So my standard deviation, let me run that one more time, is 24.73. And that is in minutes. How many values did I have? 50. So this is important. And in this case, it represents what? Movies, right? Don't forget, because I asked, what's the significance, right? So these two are the most important pieces when you're trying to figure out if data is normally distributed. Important, okay? B, create a frequency table. You can cross that out. I don't want you to make a table, just a line. I used to do a frequency table and it was a lot of work. So we're going to do this. For B, frequency line. Use this when trying to show whether or not data is normally distributed. You just make a straight line. The middle is our mean. Write it down, 102.5. Can't see that. There we go. And then we go 3. Make sure you have room because you're going to need room for this. You have 50 values to sort into these bins, right? You go 3 to the right and 3 to the left. Like so. You grab your calculator because I want you to use your decimals here. We're going to go 102.5. We're going to add a standard deviation. So plus 24.73. So this is 127.23. Keep adding a standard deviation. 151.96. And this process continues. 176.69. So you got it? Do the same thing to the left. I start with my mean, and I subtract a standard deviation every time. Okay, so that's 77, 77. 53.04. Could this be negative? Yes, it could. Like temperatures, for example. Right? If we're talking temperatures, then it could be negative temperatures, right? So there you have your bins now. So this bin right here will have any values that are between 2831 to 53, they will go in here. Anything that's 5304 to 7777 will go in here, and so forth. This is where you grab your sorted list. Okay? Grab your calculator, go stat, edit. This is already organized. Where does the 25 go? Does it go into this bin? It's smaller than this, right? So the 25, you just put it out here. Okay. Then the 73, where did the 73 go? Where would that go? In this bin right here, and this one. So 73 goes in there. 78, it goes already into this bin, because it's great. This gets you to 77, 77, so 78 is in here. And then just keep going. 81 is in here. 84, 86, and so forth. So I'm just going to tell you. Okay, I'm going to skip this step. I'm going to tell you there's going to be 34 in there. So there's 5, and another 5, another 5, another 5. So that's already 20. I probably won't do 50 on a test, right? That's going to be a lot of work. And then another 4. Okay, so keep it that way. I'm going to skip forward on my list here. So as soon as I passed 102, so all these 102s on my list were in here. 103 gets me in here. 103. And there are only 7 values that get me in this bin. Okay? Because so 125 would have been the last value in here. As soon as I get to 129, I'm in here. 135, I'm still here. 144, still there. 154, I got to jump to this next bin. 155, 162, 180, that gets me outside of this bin. It's on the extremes here. So 180 is out here, and so is the 25-minute movie, right? So those are kind of considered outliers. Now you put numbers. Obviously, if it's 1, it's fairly easy. This is 0. You've got 1 in here. You've got 34. You got 7. You got 3, 3, and 1. So you sort it. What does C is asking you to graph a histogram or frequency table. I want you to go up here and cross that out. I used to do this, but I'm not going to ask you to do that when it's checking whether or not data is normally distributed. Just say, is data normally distributed? Oh, it's asking right here, so we're just going to cross that out. So basically C is gone, D turns into C. Okay? So make sure you do that. So let's do our check here. Check. If 68, 95, 99.7 is followed. Okay, that's what you want to do. Okay, 68%. Okay, that would be plus or minus 1 standard deviation. Okay, you want to see out of the 50 movies, how many are actually found within one standard deviation. I'm going to use a color for this. One standard deviation, this is our mean right here. Let's go back and label this clearly. This is our mean. One standard deviation means, or 68% means that we're going to go back one standard deviation and then go over to one standard deviation to the right. So this, okay, is plus or minus one standard deviation. Let's do this again. Okay. So we're going to check. So we have to add 34 and 7, correct? So 34 plus 7, that is 41 over 50. And we're going to multiply that by 100. And what do we get? If you do the math, you get 82%. Versus, what is it supposed to be? 68. Okay. Does it pass? It fails miserably. Okay. Let's keep checking, because technically you're done here. Technically you're done, but I want you to see all the checks. If it's 95%, we're checking plus or minus 2 standard deviations. We're still going to compare it to 50. I'm going to use a different color for this one. Plus or minus 2 standard deviations. We go to the mean, we go left 2, and back to the mean, right 2. Okay. So to speed this up, this is already 41, I know that, correct? So I'm just going to go 41 plus 1 plus 3. So 1 plus 41 plus 3. That's 45 over 50. That is times 100. That is 95% versus 95%. Is this okay? It's perfect. Right? This is perfect. This one fails. So technically, as soon as it fails, you're done. You're saying the data is not normally distributed. Why am I doing the rest? It's just because you might have to keep going until you find that they're all correct. Okay. So 99.7, that's plus or minus 3 standard deviations. We're still checking 50 every time in this case. I'm going to use orange for this one. Go back 3, go forward 3. And you're just going to add all of these values. So 0, 1, 34, 7, 0, 1, 34, 7, 3, and 3. And that's going to be 48 out of 50 times 100. That ends up being 96% versus 99.7. Is this okay? It is. If it's 5% or less of a difference, we let it go. If it's more than 5%, not cool. Okay? So we have to conclude data not normally distributed. You have to be very clear about that. You can't just like do this and not end up answering the ultimate question, which is it's not normally distributed because of this, okay? Because of this discrepancy here. All right. What are we at? A lot of them are not normally distributed, but some of them are. So I'm going to say this. I want you to try. One second here. I'm trying to figure out. If you go with me here, I want you to try 49 and 50 in particular. Okay, in particular, 49 and 50. If you want to those are, one of them is, one of them isn't. So then you have one of each to compare to.